Our universe is vast, stretching beyond our wildest imaginations. It's filled with billions of galaxies, each one a massive collection of stars, planets, and cosmic dust. Each galaxy has billions of stars, some of which may host planets with the potential for life. But, it wasn't always this way. The universe had a very different beginning. Scientists believe the universe began from a single point, an infinitely small and incredibly dense point. This point was incredibly hot and dense, containing all the matter and energy that would become our universe. About 13.8 billion years ago, this point expanded rapidly in an event we call the Big Bang. We call this expansion the Big Bang, a moment that marked the birth of our universe. The Big Bang wasn't an explosion in space, rather it was the expansion of space itself. It was the expansion of space itself, stretching and growing from that initial point. Imagine a tiny balloon inflating to an enormous size. That's similar to what happened to our universe. As it expanded, it began to cool down. As the universe expanded, it cooled, allowing the formation of the first particles and atoms. This cooling allowed matter to form. The first atoms, primarily hydrogen and helium, appeared. These atoms clumped together under gravity, forming the first stars and galaxies, lighting up the universe. The universe has been expanding and evolving ever since, with galaxies moving farther apart over time. The Big Bang Theory is the best explanation we have for the origin of our universe, supported by extensive research and observations. It's supported by a lot of scientific evidence, including the cosmic microwave background radiation and the abundance of light elements. Scientists continue to study and explore, uncovering new details about our universe's incredible journey from a single point to the vast cosmos we see today. One key piece of evidence is cosmic background radiation. This radiation is a faint afterglow of the Big Bang. It's like an echo of that early universe. We can detect this radiation everywhere in space. It has a nearly uniform temperature. This uniformity tells us the early universe was incredibly hot and dense. It supports the idea of a single starting point for the universe. The cosmic background radiation also shows tiny variations in temperature. These variations are important. They tell us about the early universe's structure. These variations eventually led to the formation of galaxies. The cosmic background radiation is a powerful tool. It helps us understand the early universe. It gives us clues about the Big Bang. The Big Bang represents the beginning of our universe. It marks the inception of everything we know, from the smallest particles to the vast galaxies. It's the beginning of space and time, the very fabric of our reality. Before this monumental event, there was no space, no time, no matter, and no energy. This concept is hard to grasp. Our minds struggle to comprehend a state of absolute nothingness, a void without dimensions or duration. It leads to a fascinating question. What could possibly have existed before the Big Bang? Was there a precursor to our universe, or was it truly the beginning of everything? What existed before the Big Bang? This question has puzzled scientists and philosophers alike for decades, if not centuries. Some scientists believe this question has no answer. They argue that the very notion of before the Big Bang is meaningless. They argue that time itself began with the Big Bang. In this view, the Big Bang is not just the start of the universe, but the start of time itself. If there's no time, there can't be a before. Without time, the concept of before loses all meaning. This idea is based on Einstein's theory of relativity. According to Einstein, space and time are not separate entities but are intertwined. Relativity tells us that space and time are intertwined. They form a single, four-dimensional continuum known as space-time. They form a fabric called space-time. This fabric is the stage on which all events in the universe unfold. If space began with the Big Bang, then so did time. The birth of the universe and the birth of time are one and the same. This no-before theory suggests that asking about a before is meaningless. It's a question that doesn't fit within our current understanding of physics. It's like asking what's north of the North Pole. Just as there is no direction beyond the North Pole, there is no time before the Big Bang. It's a question our current understanding of physics can't answer. Perhaps future discoveries will shed light on this profound mystery, but for now, the no-before theory remains a cornerstone of cosmological thought. The no-before theory is intriguing, but it's not the only possibility. Some scientists propose a different idea. They suggest the universe goes through cycles of expansion and contraction. This is called the cyclic universe model. In this model, the Big Bang isn't a unique event, it's just one phase in an endless cycle. Imagine a universe expanding and then collapsing back on itself. This collapse would lead to another Big Bang, and the cycle would begin again. This model offers an alternative to a single beginning. It suggests the universe is eternal. However, this model has challenges. Current observations suggest the universe's expansion is accelerating. This acceleration makes a future collapse unlikely. Section 5. Beyond our universe, the Multiverse Hypothesis. The Big Bang might not be the only one. Some theories suggest our universe is just one of many. This is the Multiverse Hypothesis. Imagine a vast landscape of universes. Each universe has its own laws of physics. These universes can collide or interact. These interactions could trigger new Big Bangs. This idea is still very speculative, but it's supported by some theories of physics. String theory is one example. String theory suggests there are extra dimensions beyond our perception. These extra dimensions could contain other universes. The multiverse hypothesis is mind-boggling. It pushes the boundaries of our imagination. Section 6. From quantum foam to reality, the quantum universe. Quantum mechanics is a strange and wonderful world full of mysteries and paradoxes that challenge our understanding of reality. It governs the behavior of the very small, from subatomic particles to atoms and even molecules. Some scientists believe it played a crucial role in the Big Bang, the event that gave birth to our universe. They suggest that before the Big Bang, the universe existed as a quantum foam, a frothy, turbulent sea of energy. This foam was a chaotic sea of energy, with particles popping in and out of existence, governed by the laws of quantum mechanics. It had no space or time as we know it, just a roiling, unpredictable quantum state. Random fluctuations in this foam could have triggered the Big Bang, setting off a chain reaction that led to the creation of our universe. This would have caused the universe to transition from an uncertain quantum state to a more ordered one, with space, time, and matter emerging from the chaos. This theory is highly speculative, and many questions remain unanswered, but it offers a glimpse into the weirdness of the quantum world, where particles can be in multiple places at once, and events can happen without a clear cause. It suggests that the universe's origin might be rooted in quantum mechanics, a field that continues to surprise and intrigue scientists to this day. Section 7. The Unseen Hand. Philosophical and Religious Perspectives. Science offers explanations for the universe's origin, but philosophy and religion also grapple with this question. Some philosophical traditions suggest the universe is eternal. Others propose a first cause or a prime mover. Religious beliefs about creation are diverse. Some religions believe a deity created the universe. Others have different creation myths. These perspectives provide cultural and spiritual meaning. They offer different ways of understanding our place in the cosmos. While these viewpoints are not scientific, they are important. They reflect humanity's enduring fascination with our origins. Section 8. The Future of Cosmology. Unraveling the Ultimate Mystery. The question of what existed before the Big Bang is a challenge. It's a challenge that inspires scientists. New telescopes are being built. These telescopes will peer deeper into space. They will study the early universe in greater detail. Scientists are also developing new theories. These theories will push the boundaries of our understanding. The study of the universe's origin is an ongoing quest. It's a journey of discovery. We may never have a definitive answer, but the pursuit of knowledge will continue to drive us. It will lead us to a deeper understanding of the cosmos and our place within it.